Hey, what's up guys? It's Simon back again. Today we're going to be doing another problem, removing linked list elements. Very interesting. So yeah, they're going to give us a value, and if we find an element in our little input list that has that value, then we're going to delete it. So if you don't know how to do the delete operation, then go watch my video on designing a linked list. Okay, anywho, so first let's check to see if head is equal to null. Then we're simply going to return null. And then otherwise I'm going to create a list node called I'll call it previous, and that's going to be equal to a new list node. Let's just create it with the value 69 because that's just what I do. And then also going to create another one that's called pseudo prev, and that's just going to be equal to previous. I'm just going to doing that so we can return that at the end. You'll see. Okay, so then while head is not equal to null, firstly I need to, the whole point that I'm making this previous node is so that we can be one in front of or behind the head. So I want to be one value behind it, just so that we can make the delete operation a lot easier, especially at the edge cases. So like right now I'm going to set previous.next equal to head. Yeah, so that way we have our edge cases there. So then if head.val is equal to val, then previous dot next is equal to head dot next. That way we skip the head value, because if you think about it, previous is always one behind. So say head is currently at 2, then previous is at 1. So previous's next value is currently 2, but we're resetting it to head's next value, which is 6. So whoop, 2 is now eliminated. So if the value was 2, that's what we'd want to do. Okay, and then else previous is equal to prev.next. So if, say we're on 2 again and previous is here, we don't want to delete that, so we just move it on up. Alright, and then we always are going to increase head by 1. And then finally we just need to return pseudo prev.next, because that will be the first head value. So that would be this altogether, because if we just return previous, then it will give us just like one value. So yeah, basically the main meat of this problem happens right here, where you basically have a pointer that's always going to be 1 before, even if it's the first node. So say that this node here was 6, we would still have previous here, and we could skip it. And then same thing at the end. So that's why I made that previous node, because it works for all the edge cases, and it'll pass all the test cases. Check it out. See? So it passes all the test cases if you do it that way. So yeah, we just want to have a value 1 behind so that we can just skip the head's current value. We check that value to see if it is one that we want to delete. So yeah, pretty easy problem. Thanks for watching. Peace.